Hello guys, welcome back to the Pepcoding. So in this video, we are going to discuss our next question, that is kth smallest prime fraction. Okay, so this is the statement. Let's take this onto the open board. Okay, now in this question we have sorted integers array having 1 and some prime numbers. Okay, so array is look like after 1 we have some prime numbers, and we need to find the kth smallest fraction by using numbers that are present in the array. So we need to find the fraction. We must divide the numbers that are present in the array to find the fractional value. So for dividing this, our first main rule is for the fraction value. Our main rule is our numerator is less than our denominator. Okay, it will gives the fractional value to us. So it will find we must find we are finding multiple number of pairs here. So the pairs will be look like that: 1 by 5, 1 by 3, 1 by 2. For example, these pairs are made here. So this that pairs gives some fractional value to us. So we are satisfying this condition here. By using that, we have some multiple number of pairs. For example, we have some multiple number of pairs, and if our k is 3, then if this function this pair sorry this pair is gives third smallest value that are present in this number of pairs. Okay, if this pair gives third smallest value, then we need to return a array that contains numerator and denominator value. So it will we need to return this type of answer as an answer. Okay, we need to return an array, this type of array as an answer. Okay, so for satisfying this condition, numerator is less than denominator, this number of pairs that we can made from this array. Okay, now if our k is 3, then we are returning 2 by 5 that is in between in array. Okay, the array contains numerator comma denominator. So now k have some constraint. K is greater than 1 and less than n into n minus 1 divided by 2. So k's have some constraint. K's constraint is this. So basically, what is n minus 1? N minus 1 is the sum. Okay, which sum? Let's talk about that first. Now our main condition is that our numerator is less than our denominator. So it will give the fractional value to us. So our numerator is less than denominator. If our numerator is equal to denominator, then it will be equals to 1. Numerator is equal to denominator. We only want this condition. We can't afford this condition here, because we want the fractional value. If our numerator is greater than denominator, then it will gives us more than one value. Okay, if our numerator is greater than denominator, it gives more than one value, and we want only less than one value. So our main condition is this. So for this condition, if let's take this array little bits. Okay, so basically from this condition, what is how much possibility that one can go with the denominators from this array. So what is the possibility? How much the possibility is? So array size is 4. Okay, for satisfying this condition, that condition is numerator is less than denominator. For satisfying this condition, one will get with the three denominators. All the three are in larger in terms of value from 1, and we can get with the three limits. So we have three count. For 1 we have three pairs: first one, second one, and third one. For satisfying this condition, we have three pairs here. For the 2, how much pair? For the 2 we have three pairs, that is first one is this and second one is this. So we have two pairs. For 3, how much pair that we can go with? Only one pair we can find, and we can go with that will satisfy this condition. Okay, now this is the sum, and it will prove that that is it will goes to the n minus 1. Okay, now what is our approach to solve this question? Basically, let's take this array onto the next page. In this page. Okay, now let's take a faith on one function that will gives in return. We are giving that function as an input array and target. What is the target? Let's talk about that. And we have expectation on that function. It will return us count, numerator value or denominator value. Okay, this function returns us count, numerator or denominator. So if this function if we have this function, and our work is that we need to use this function efficiently. So for using this function efficiently, we need to apply binary search for solving this question. Okay, so for the binary search, we have low pointer and high pointer. We need low pointer and high pointer and finding the mid pointer. Okay, now what is the lower pointer here and what is the high pointer? So our high pointer is that our condition is numerator is less than denominator. So denominator is greater from numerator. So our answer is lies between from 0 to less than 1. From 0 to less than 1. So our higher pointer is set at 1. So maximum we can go with 0.999. Okay, 0.999. So this is the answer that we have possible in this question. Now, so this is the high pointer, and the low pointer is that if we are dividing the smallest value with the largest number that are present in the array, it will give us the smallest fractional value that we can calculate from this array. We can calculate from this array. So 1 by 5 is 0.2, and it will give the smallest fractional value that we can calculate from this array. So our low pointer as set at 1 by 5. Now we are taking the average of these two and finding the midpoint. If our midpoint is here, and let's say this 1.2 divided by 2, 0.6, let's take 0.6223. Okay, let's take 0.622. If our midpoint is here 0.622, or let's take this 0.65. Okay, let's take this 0.65. Okay, now we are providing this midpoint as a target for this function. So what this function works? What is the function works here? The functions work here. That function return us count, numerator value, and or denominator value. So this is the lower pointer. Both are low pointer, and the higher pointer is this. One is present at this point, and it is the highest point. Okay, now we are passing the midpoint here as a target, and our target is somewhere lies between here. If this is the 6.0 and it is 6.65, and our target is 0.6, it is lies somewhere between there. Okay, it is not the same, it is not always same, or it is not always same as the fraction value. Okay, so it is lies somewhere between in these two. So we can say that this is our target point. Okay, our target point. And what is the expectation? What is the expectation of us what is our expectation from this function is that function returns count. Which count? It returns the count from target to low. It returns the count from target to low, that how many pairs are contains. Okay, again it returns the count that from low to target or target to low, how much number of pairs that portion contains, how much number of pairs that what we can say that how much pairs in this portion contains. Okay, if our target is 0.6, then we have 1 by 5 1 by 3, 2 by 5, 1 by 2, and 3 by 5. So from this point to this point, from this point to this point, we have 5 number of pairs. So it will return 5 here. And which numerator or denominator? It will returns the numerator or denominator value of this function. Why only this function? So because it is this function is nearest from that target value. This function is this pair is nearest from that target value, and it gives the maximum fractional value in between this. It gives the maximum fractional value in between this all these pairs. So it will return us numerator as a 3 and or denominator as a 5. So this function return us this value. Now if our k is, for example, k is 3, our k is lies between here, lies between somewhere here, 2 by 5. Okay, 2 by 5, and our count is 3 at this point. Our midpoint is this. Our count is 5. We are checking that here. What we are checking at? We are checking that is our k is equal to count. Okay, let me remove this first. Okay. Now what we are checking here? Is our k is equal to count? Is our 3 is equal to 5? Is our k is equal to count? No, it is not. So we are checking that where it is lie, where on which side of that target, on which point, on which side of that target the value is lie. Now we are checking that our k is less than count. Basically our value is lie on that side from low to mid. So for that we need to update our high point as a midpoint. So we can now after updating high at this point, so we are finding the mid, and it will again somewhere at this point. If our mid at this point, then we have that point and we have that count as well. So basically if our count is less than k is less than count, our k is less than count value, then we are updating our high point as a midpoint. Okay, after that, if our k is greater than count value, then we are updating our low point as a midpoint. If our count is 2, if our count is 2 and our k is 1 2 3 4 5 6, our k's value is 6 and count is 2. Let's take count 5, same count, not for better understanding. Count is 5. Okay, our count is 5 and k is 6. Now we are checking, is our k is greater than count? Is our k is greater than count? Yes, it is. So basically we want this value and we have this value now at this point. So we need to update our low as a mid. So we are updating our low as a mid, and we are finding our midpoint somewhere here, and it will contains from this point to this point only one count. Okay, only one yes, only one count, and it will return the numerator or denominator value to us. So basically let's do some code here for that. So this is our Nado's ID. Now applying binary search over this. So finding low point as the array of 0 divided by double array of n minus 1. So why we are doing this for the low? So we are taking this point as a low. Why? Because we want the smallest value from that we can produce from the array. So our low point is this. Higher point is present at 1. And let's find the n also, that is array dot size. Okay, array dot size. Now after that, the while loop is run until low is less than high. Okay, now first work we have to do, first finding the midpoint. Low plus high divided by 2. Okay, this is the midpoint. Now we have faith in one function that will return us count numerator value or denominator value. this function gives us count numerator or denominator value. Now let's write this. The function, we are providing this array or mid, and it will return us count numerator or denominator. Okay, numerator or denominator, and we need to store this into some vector of int of count. Say this as a count. So it will store into count array, and it will return that count numerator or denominator value. After that, we are checking that if our k is less than count of 0, this function return us, basically this function return us, let me this function, okay, this function return us count is equal to, in an array, first at the 0th position, 0th index contains count, first index contains numerator, or second index contains denominator. So basically we are following that property here. We have the abstraction, we have the faith on that function, it will give these values. So we are checking, is our k is less than that count? If it is, then we are updating our midpoint here. Else if is our k is greater than count of that count? If it is, then we are updating our low as a mid. Okay, low as a mid. And in the last part, if both are equal, then we got our value. Then we need to return the answer into the array. So we are making, and that array contains only numerator or denominator. So we are giving that size. So our answer of 0 contains count of 1. Why? We will discuss here. At this point, count of 1 contains numerator, or count of 2 contains denominator. So we are writing that answer of 1 contains count of 2, and just return this answer from here. If we can't find that, then this is for while. If we can't find that, then return the empty array. Okay, now we need to make this function. So let's first erase this. Now we need to make this function. So for this, let's take a array that contains 1, 2, 3, 5, 7, 11. Okay, and for this function array and target, for this function we are fixing the denominator point here. Denominator, if our target is at this point 5, then we are checking that is 1 by 5, 2 by 5, or 3 by 5 is less than equals to target. If it is, then we are updating our denominator. We are fixing the denominator first. Again, we are fixing here our denominator point. We are fixing denominator. If our denominator at this point, then we are checking that is 1 by 5, 2 by 5, or 3 by 5 is less than equals to target. If it is, then update our denominator to this point. Now we are at this point. Then we are at this point, and our main condition is numerator is less than denominator. Okay, it will give the fractional value. If we are updating our denominator value, then it will give the less value. Okay, it will give the smaller value from this. It will give 0.2. If we are dividing this with 7, it will give some another value that is less than this. So we don't need to check these numbers for these numbers for this point, this target. If we are checking that again and again, then it will take some time. Okay, So basically we don't need to check for this number. Why? We are increasing the denominator here. So we can easily say that 1 by 7, 2 by 7 or 3 by 7 is less than equals to target. We can say that. But if we want to add some another value here, then we need to check for that. Is 5 upon 7 is less than equals to target? If it is, then we can add that. If it is not, then we can't add that. Now all the pairs, possible pairs we have, now we are updating our denominator point again. Now again we are increasing the denominator point. So can we have to check for this number? No. Why? All the values that are smaller, all the values, let's take example. If for this target all the values are smaller for these numbers, then did not check, we did not uh, want to check that again. So we can say that 1 by 11, 2 by 11, 3 by 11 and 5 by 11 is the less than values from the target. But for adding the new value, we need to check that is 7 by 11 is less than equals to target. So basically we are fixing our denominator here and checking the numerator value. Is this is the less than target? Is this value is less than target? Is for example, is this value is less than target? If this value is less than target, if it is, then we are updating our denominator point. So basically how to write the code for this function. The function's work is return the count as numerator value or denominator value. Function's main work is this. Now let's write some code for that. Okay, so this is the function. Okay, now at this point we are writing the code, some code with the understanding of this. Now let's erase this, all these things. Erase all these things. Now first condition, we are fixing our numerator point first, and we are checking that I point. From that I point, is this condition, is this pair is less than our target value? If it is, then add it, and if it is not, then update our j. Again checking that, update our j, again checking that, again checking that. So at this point we need to take I point at 0 and for loop from int j is starting from 1, j is less than n, and j should be plus plus here. This is a closing bracket. Okay, uh, let's open again the open board. Sorry for the inconvenience. Okay, okay, okay. So we are at this point. Now in the for loop, what we are doing, in that for loop, what we are doing, if our target is this and our pair is this 3 by 5 is less than target for this point, for this point, if it is, then we do not want to check that again. Why? This takes sometimes. So this value is always being a smaller value than the target. So we can say that here our array of I upon j, array of j is less than equals to target. So for here we are doing that array of I is less than equals to array of j into target. So we are converting this function into this for not for the decimal, for the what we can say that for the decimal points. Okay, we can't get the proper decimals here, so we are checking that if our array of, sorry, while if array of I is less than equals to array of j into target. If it is, then let me, if it is true, then we are doing here I plus plus. Okay, only I plus plus. So we are not checking again and again for the new what we have said, for the new denominator. We are not checking for that again and again, and we can easily increase our count as plus equals to I. So we want count here, so we are initializing count at, and the count is 0 for the first time. Now we are increasing our count here. Now we have the count. We for what is our expectation for that function that will return count, numerator value or denominator value. Okay, now we have count. Now our work is numerator or denominator. So first we have to initialize our numerator or denominator here. So we are initializing our numerator is 1 and denominator is 11. So it will give the smallest fractional value. If we are dividing the numerator here 1 by 11, it will give the smallest fractional value. Okay, now we want these numbers also, and that will add the point. Okay, now we want that values also. Now what we are saying that is our array of I minus 1 of array of j. If this is greater than numerator upon denominator, if it is greater than this, then we need to update this value. Okay, so what is I want to say here, at j it as this point and I at this point. Now we are checking that is our 5 by 7 is our let's write this at here, is our 5 by 7 is greater than 1 by 11. Yes, because why? Because our numerator value is less and denominator value is greater than, and at this point our numerator value as compared to this is greater than, and as compared to this is smaller than. So it will always give the greater value, greater fractional value than this. So we are writing the while loop for this. While loop is saying that array of I into denominator is greater than array of I minus 1 and array of j into numerator. So if this condition is true, then we are updating our numerator as a array of I minus 1 and updating our denominator as a array of j. Okay, and after that we are returning, okay, from this point. So this is the code. Let's copy this code and making the function first. Vector of int function. It contains vector of int and percent array and double target. Okay, it contains this, and just paste this here. Now we are using n at this point. So our n is array dot size. Okay, array dot size, and we are not initializing our numerator or denominator, so we need to initialize this first, and denominator is array of n minus 1. Okay, and at this point we need to return a array that contains count, numerator or denominator, that is answer array. Its size is 3, so we can say that answer of 0 contains count, answer of 1 contains numerator, and the answer of 2 contains denominator, and return the answer array from this point. Let's try to run this code. So it is run for the first test case. Let's try to submit it. Will it be run for the all test cases or not? So all the test cases are passed here. So this is the code for this question, and I hope you understand the question and the solution of this question. Thank you for watching.